Hello everyone, welcome to Tech Starter. If you're new here, don't forget to hit that subscribe button and click the bell icon to stay updated with our latest videos. Today, we're diving into the fascinating world of Elasticsearch. Whether you're a developer, data analyst, or just someone curious about search technologies, this video will give you a comprehensive overview of what Elasticsearch is and why it's such a powerful tool. In recent years, there has been a huge increase in data. This affects how we search for information and analyze it. Imagine searching for a tiny needle in a huge haystack. That is what organizations need to do with their data. They want to find specific information quickly. Besides searching, we also need to look at the big picture on how we combine and summarize the data to understand trends and patterns. Elasticsearch is one of the modern search engines that helps us to find and analyze the data effectively. Elasticsearch is a powerful and popular open-source distributed search and analytics engine. It is built on top of the Apache Lucene library. Elasticsearch can perform near real-time search and analytics. It is designed to handle large amounts of data efficiently. Elasticsearch is widely used for the following use cases. Search and analytics. Elasticsearch helps to find information quickly and analyze the data effectively. For instance, it is used in e-commerce websites to provide accurate search results. Log analytics. Elasticsearch collects and analyzes logs from applications and infrastructure, aiding in monitoring system performance and troubleshooting issues. Security and threat detection. Elasticsearch detects security threats in real time, enhancing enterprise security. Application performance monitoring. Elasticsearch provides insights into application performance, helping developers to optimize their code. In this video tutorial series, we explore the concept of search, and we will briefly look at how search has evolved over time, starting from database-backed searches to today's sophisticated search engines. So, what is an ideal search engine? Imagine you are searching for a new smartphone online. You visit various websites hoping to find the perfect smartphone. However, the search results are all over the place. One website recommends phone cases, another website suggests phone chargers, and another website displays unrelated gadgets. We notice that some search engines lack helpful features. They don't offer suggestions as you type, and they don't correct your typos. Plus, the search results often miss the mark. But then you try Amazon. As soon as you type smartphone, a drop-down appears with relevant suggestions. Amazon's initial search results are spot on, and you can either sort the results by features like price or customer reviews. In today's digital landscape, search engines play a crucial role. Organizations embrace them because they understand the value a search engine can bring. Elasticsearch is one such modern search engine, embracing search and analytics with speed and performance at its heart. When we are working with search engines like Elasticsearch, we encounter two types of data, structured and unstructured data. Structured data follows a specific format or pattern. It follows a defined schema and is easily searchable because it is well organized. Data in a database is considered structured data because before it is stored in the database, it is expected to follow a strict schema. Because it is well organized, structured data is easily searchable. Imagine finding a specific book in a well-arranged library that's structured data. Structured data is like a tidy filing cabinet. Everything has its place. When we perform a query against structured data, such as a database, we're looking for specific records that match our search criteria. In other words, the query will return results that exactly match our search criteria. The idea of exact matches means that we're interested in finding documents that precisely meet the conditions we specify, without considering any degree of similarity or partial matches. Imagine we have a database of books, and one of the fields is the book title. If we search for the exact title, Hamlet, we expect to find books with a title exactly matching Hamlet. We won't get results for variations like The Tragedy of Hamlet or Hamlet, Prince of Denmark. Only the exact match counts. Elasticsearch stores data as documents. When we perform search in Elasticsearch, Elasticsearch will use a concept called relevancy. Relevance refers to how well a document matches a specific query. When you perform a search, Elasticsearch assigns a relevance score to each document based on how closely it aligns with your search criteria. By default, search results are sorted in descending order of relevance. The highest relevance score matches will be sorted on top of the results. When searching for the term Hamlet in Elasticsearch, the search results are sorted in descending order of relevance. Highest relevance score matches will be sorted on top of the results. Let's consider the following book titles. Hamlet, Prince of Denmark. This title contains the exact phrase, Hamlet, so it receives a high relevance score. The Tragedy of Ham, although it doesn't match the exact phrase, it contains 3 characters that partially match Hamlet. As a result, it has the second highest relevance score. Ha Soliloquy. Similarly, this title contains 2 characters that partially match Hamlet, earning it the third highest relevance score. Unstructured data is messy and doesn't follow any specific format. It includes things like blog posts, research articles, emails, PDF, and audio or video files. Modern search engines rely heavily on unstructured data. Elasticsearch can search through large amounts of unstructured text to find specific words or phrases. It works well with both structured and unstructured data, allowing you to search and index them together. Search supported by a database. This is how a database-based search normally works. The user starts a search using the app or UI. The business layer processes this search and gets it ready for the database. The database layer talks to the database to run the search and get the results. The database stores the data and sends the results back to the database layer. Old search methods relied on traditional relational databases and multi-layered applications. These used SQL queries with clauses like where and like for searching, but they weren't very efficient for full-text searches. Modern databases like Oracle and MySQL can handle full-text searches like searching blog posts or reviews, but they might struggle with real-time searches under heavy loads. Elasticsearch, a distributed search engine, offers instant scalability that most databases can't match. A search engine without full-text search capabilities may not provide relevant results or handle large volumes of data in real time. Database versus search engines. When creating a search service using a traditional database, we need to check if the database can meet our needs efficiently. Most databases are good at storing large amounts of data, but aren't great for full-text search for several reasons. Indexing and search performance. Full-text search needs efficient indexing and fast search capabilities, which traditional databases aren't built for. They may struggle with large data volumes, leading to slow queries. Search engines like Elasticsearch are designed to handle lots of text data and provide quick search results. They have advanced search features like fuzzy logic and synonyms, which traditional databases lack. Search. Traditional databases rely on exact matches, which works for structured data, but not for natural language queries. User queries can be misspelled or incomplete, and traditional databases can't handle these well. Modern search engines support fuzzy matching, which helps with misspelled words. Data structure. Traditional databases often spread data across multiple tables, making it hard to search across fields in one query. They aren't designed for unstructured or semi-structured data common in full-text search. Text analysis and processing. Search engines can handle multiple languages and character sets, performing text analysis to extract meaning. Traditional databases aren't optimized for this. Scalability and flexibility. Full-text search engines can handle large data and high query loads. Traditional databases may struggle with scalability when dealing with lots of text data. Search engines are built to handle unstructured data, while databases are optimized for structured data. This makes traditional databases less suitable for full-text search. Specialized search engines like Elasticsearch are used for advanced text search. Some databases have added text search features, but they may not match the performance and scalability of specialized search engines. We can use both traditional databases and search engines together. For example, a database can handle transactions, and a search engine can handle search and analytics. Elasticstack is a suite of products that will help us to perform the search, index the data, and so on. Elasticstack contains the following components: Beats, Logstash, Elasticsearch, which is the core of the search engine, and Kibana. So, the combination of all the above components, that is Beats, Elasticsearch, and Kibana, is popularly known as Elasticstack. So Beats are basically your data shippers that brings the data into Elasticsearch from various sources. Logstash is an ETL engine that will extract the data, transform and load the extracted data as per our business requirements. Coming to Elasticsearch, this is the heart of the search engine. Elasticsearch will contain REST web services, which can be invoked using a REST client like Postman. We can use these REST web services to query the data, update the data, or create a new data in Elasticsearch. Instead of using a REST client, we can also use Kibana, which is a web console user interface that will help us to access Elasticsearch REST web services and see the data. That wraps up our overview of Elasticsearch. I hope you found this video informative and now have a better understanding of how Elasticsearch can be a game changer for your search and analytics needs. If you liked this video, please consider subscribing to the channel.